All right, today we're going to be talking about is our new unit of exponential functions. And within that, we're going to talk about geometric sequences. So let's get started. So for geometric sequences, you need to think about arithmetic sequences, which is what we've already done. So an arithmetic sequence must have a common difference, so we talked about that, and that's the amount between each number. So we used to do, or we've learned about it, the explicit formula. So the term 1, and you look for sequence. So you have your first term, your common difference, and then whatever the next numbers are. So let's go ahead, let's write an explicit formula for this sequence. So we started at 5, that's our term 1. And then from here, it looks like we're adding 6. So our common difference is positive 6. So now let's put it together where we have the term, whatever term we're looking for, is 5 plus 6, and then this would be any other terms that we'd be looking for. So if we want to find the 15th term, you're going to substitute that into here, and you get 5 plus 6, and then remember it would be 15 minus 1, and once you put all of that together, it's going to equal 89. And then we've also learned with your arithmetic sequences the recursive formula, and that's just saying what the term is relating to the term before it. So we're going to add or subtract the common difference, so it's similar to slope, and there's different ways to write it. So you can write it either this way, or you can write it this way. So either of those ways work. So let's go ahead, let's get started with this one. I already filled in the information for you. So we're given the recursive, we want to write the first 5 terms. Well here, this is your difference, the common difference. And then this is your starting point. So all you gotta do is plug it in there, subtract 6, you'll get negative 23. Subtract 6 more, get negative 29. Subtract 6 more, negative 35. Subtract 6 more, negative 41. And then for this one, we're going to write in a recursive equation. So you have to know that 5 is your starting term, and the common difference to get from here to here is you subtract 6 each time. So the common difference is negative 6. So to put it all together, we say any term, what you do is you take the term before it minus 6. So if we start at 5, that's all you do. All right, so now we're going to get into geometric sequences. So before, what we did here is we're either adding or subtracting a common difference, right? So geometric sequences, what we're doing is we're multiplying or dividing. I'll zoom in. So here, to get to 2 to 4, you would multiply by 2, and you would double to get to 8, multiply by 2 to get 16, and then multiply by 2 to get 32. So that's the pattern. Or you can also divide. So in this case, if we were to either multiply by 1/2 or divide by 2, we'd get 10. Divide that by 2, you get 5. And divide 5 by 2, you get 2.5. So in order to be a geometric sequences, the numbers need to have a common ratio. So common ratio is the amount between each number in a geometric sequence that you multiply to get to the next number. To determine the ratio, you can just divide each number from the number following it in the sequence. So really, you would work backwards, and we would go 10 over 20. So that's what that means here. And following it in the sequence. So geometric sequences start with term 1. So very important. So let's look here. So this is your first term. And then to get from 2 to 6, what do we have to do? Well, if we're not sure what the ratio is, remember, you go this over that. So we did 6 over 2, which equals 3. So then that's telling us we're multiplying by 3 each time. Now, to get from 8 to 19, or to 9, excuse me, 18 to 9, we would go 9 over 18, and we get 0.5 or 1/2. All right, so now let's start putting some of that information over here. So here we said we were multiplying by 3, so our ratio is 3. And then here we said it was 1/2 or 0.05. So for here, what are we doing to get from here to here? I want you to write what that common ratio is. And then now let's look here. We want to know to get from -4 to 8, what are we doing each time? Well, in this case, if you were to go, 8 over -4, you get -2. So that's how you know r is -2. So what you're doing is you're actually multiplying by -2 each time. So multiply by -2, multiply by -2, and continue the pattern. All right, now this one, it looks a little tricky at first because when you do this, if you're to take 1/8 over 1/2, that is pretty tricky. So if you were to do 1/8 divided by 1/2, remember when you're dividing, you're really multiplying by the reciprocal. So this is the same as 1/8 times 2 over 1. So that's where we get the 2/8, which equals 1/4. So that's where we got the r equals 1/4, your common ratio. So, or it obviously tells you that. So you can just multiply. So 1/2 times 1/4 gives you 1/8. 1/8 times 1/4 gives you 1/32. 1 over 32 times 1/4 gives you 1 over 128. And then this times 1/4 gives you 1 over 512. All right, so now what we're going to do is we're going to take this information and we're going to fill out the sequences, either for explicit or recursive. So for the first one, we have explicit, and that is very similar to what we did before. You have your starting term, but instead of a common difference, you have a common ratio, and then instead of in parentheses, it's your exponent. All right, and your recursive is also very similar. You're just taking whatever term times a ratio, or whatever the previous term times a ratio to get your term. So remember again, your term 1 is what your sequence always starts with. So let's look here. Oops. So if we start at -4, to get to 20, you would have to multiply by -5. So when you're multiplying by -5, and we got that because it's 20 over -4, which equals -5, and then that's where we got our common ratio from. So now that we have our common ratio, now we can go ahead and substitute it into this formula. A sub n, so this is any term you're looking for, is you take your first term times your common ratio, and then n minus 1 is your exponent. So if we have to find the sixth term, we're going to substitute in 6 there, and we will get 5, and then we'll get 12,500. And then for recursive, we just say our first term's -4, and then it would be whatever the previous term is times -5. Or whatever term you're looking for, and then you have this information here. So for the recursive, like I said, it looks a little different, but it's kind of the same thing we've done before, but instead of adding or subtracting, you're just multiplying. So in this case, you have your a sub n plus, oops, oh yeah, -5. Okay, yeah, we're good here. All right, just make sure I wrote down the right thing. So here we go. All right, so now remember, to get this, you have to do 9 over 18. And then that gives you your common ratio. And then we said our first term is 18. We said the common ratio goes in the parentheses. And then your exponent is n minus 1. So if we want the sixth term, you just substitute in 6 here. And you're going to get it to the fifth. So it's going to be 18 times 1/2 to the 5th power. The 5 only goes to the 1/2. You're going to do that first. then multiply by 18. And you should get 0.5625. And then to write in recursive formula, we're going to take the term after and we're going to do whatever term we're looking for times 1/2 if your first term is 18. So it would be 1/2 a sub n. All right, I want you to try this one. I gave you a hint with the common ratio, so it should be 3, and then you're going ahead, fill out the rest. All right, now for this one we have to determine, is it arithmetic or is it geometric? So, and then write the explicit equation. So from here, to get from here to here, it looks like we're multiplying by 3. So let's just double check, because, or are we adding 10? So we need to figure out, is it adding 10 again? Yes, it is. So, because if you multiply by 3, you're not going to get the same thing. So since we are adding 10 each time, then it is an arithmetic. And since it's adding 10, it's a common difference of 10. So we're going to go, our term that we're looking for is 5, which is your first term, plus the common difference of 10, and then times n minus 1. So if it's an arithmetic, we can simplify. So we can just make that 10n minus 5. And then recursive is where you take whatever term to find the next term plus 10, and you start at 5. All right, for the next one, if I were to go here, I would be like, oh, is it minus 7? Well, if we subtract 7 here, it doesn't work. But if we divide by 2, does that work? Yes, it does. So remember, if we were to go 7 over 14, we get 1/2. So that's where we got the common ratio from, is 7 over 14. So since we're dividing by 2, you're actually multiplying by 1/2. All right, so our first term is 14. Our common ratio is 1/2, and then we have our exponent of n minus 1. This one we don't have to do because it's not arithmetic, but for recursive, we can write that. And then we say it's the term previous times 1/2 will give us what we need if we start at 14. Or we can say whatever term we're looking for is 1/2 a, or 1/2 times whatever term is before it. So I want you to go ahead and try this one. And then for this bottom part, it gives you an equation, and you need to figure out, is it this, arithmetic, geometric, what's the ratio or difference, and then find what the first term is, and then list the first 3 terms. So for this first one, it says right here, since we're not multiplying anything, it's just telling us this is arithmetic, because that's what the equation fits. The common difference is -2. Your first term is 14. So what that means is you subtract 2 each time. So -2 minus 2 for the first 3 terms. So that'd be your answer. Now this one, since we're multiplying and we start at -2, this is going to be geometric. So your common ratio is 2. And then what we need to do, your starting term is -2. And if we start at -2 and we're multiplying by 2 each time, that's all you do. So you get -2, -4, -8. So I want you to go ahead and try those. And then for this one, what I would suggest is make a table to organize your information. So in year 1, there's 5,120 accidents. In year 2, there's 4,096. As you can see, I put my information here. And in year 3, there were 3,276.8. So then I put my information there. Write an explicit formula, and we want to know how many are there in year 8. So we're going to round to the nearest tenths. So all we got to do is figure out what the common difference is, or the common ratio. So we're going to take this over this. and I got 0.8. So that would be your common ratio. So that's what's going inside the parentheses. Your first term is your A1, and that's going here. And then if we want to know how many in year 8, we're just going to substitute an 8 there. So that's what I did here. So this to the 7th power. And remember, you're going to do that first, then multiply by that. All right? And your answer should have been 1073.7. All right, and then that is our geometric and arithmetic sequences.